we are designing the Gmail, our own Gmail. So this is a kind of series where we design or where we discuss most of the system design services. We are also maybe discuss about the terminologies we can use in system design, and we will see how we can scale our application or optimize our application based on the different businesses we have, maybe other people have. Okay, so I think you can see my screen properly. So let's understand what we are going to build in Gmail. Okay, so okay, so as you can see, we have some functional and we have some non-functional feature. The meaning of functional and non-functional feature means the functional feature which is used by the user from our application or in our application, and non-functional features are those features that actually we consider before building any system, like how much users our system may have, or how many people use it, or we need our application highly available, or we want our application very fast so that we have low latency. So these are the non-functional feature. And if we talk about the functional feature, that is like we can send the email, we can search email, we can receive email, we can do the spam detection. As you know, in the Gmail we can send attachments when we send the email, we can register the users, and we can create files. There are a lot of features we will discuss in this video. So whenever we are building some system, we need to do some estimations for our system. Like, as we say that our system may have 2 billion users, so that is a huge amount of users. So if we know like what number of users or how our application is going to be used, then we can decide what type of infrastructure we may need or what type of traffic we may got in our application. So mostly I basically do a capacity estimation in the form of assumption. So similarly here we will assume something and we will come up with the numbers, and this is a very quick thing. So as we know, we have 2 billion users, and we are considering that each user is sending 50 emails every day. So this is the 50 emails sent by every users. And let's suppose if we have 2 billion users and around 5% of users who is sending emails, or the total number of emails we have, if only 5% of user is attaching the attachment, so we are taking the 5% user attaching the email while sending the email. The another thing is email size. Right now the email content we are passing, I am taking the average, which is 200 bytes, which consists of string, integer, or the whole email body. I am taking that. And in that way, if I will see how much traffic or how much total users is going to be inside my system and how they interact. So 2 billion users we have, and I said like every user is sending 50 emails, so it is around 100 billion emails every day. And in terms of write, so basically there are 100 billion writes every day we are going to see in our application. And if you see this, we are simply dividing that 100 billion by the total number of seconds we have in a day, then it is around 1 million, around 1 million per second we may get so in 1 second we may get 1 million of write requests. So this is the number of requests we are going to get in this Gmail application we have. So now that number of Gmails we have, that number of attachments people are going to send. So obviously we need storage. So we don't have unlimited storage. We need to assume or estimate it properly so that we are not going out of storage. So here you can see that we have total 100 billion users. We have 50 emails per day. And if you see the total side without attachment is for 50 emails if each person, and 200 bytes for each email, then it is around 20 terabyte per day. This is an assumption, right? And if we talk about the size, the people who is sending email with attachment, so I said that is 5% from 100 billion email, that is going to be 5 billion email. And if I take that each attachment size is 2 MB, then by doing this calculation it is around 10 petabyte per day. And this is again the assumption I am taking. Obviously the attachment can be 20 MBs, but I am taking the average here. So whenever we are designing a system, in a system design we don't have the real stats, right? So in that case we just simply need to do some assumption and come up with the numbers, so that we can state all these things to the interviewer, and we can move on. So we now understand how many writes are there. We now understand what are the total numbers of capacity we need every day. Now what are the number of reads is going to happen in our application. So let's suppose each person is opening their apps 10 times per day, then the total number of reads, let's suppose each person is opening 20 emails in every session, so it is around 200 emails per day by one person. So we have 2 billion users, and if you multiply all those values, it is around 400 billion reads per day, and every second it is around 4.5 million per second. And one more takeaways I'm just going to give you in this whole thing, that is, whenever you are going to build a system and you are doing estimations, every time the read should always be greater than the writes in most of the scenarios, right? And there are some other background processing estimations also. So let's suppose when we are attaching some file to email, we need to check whether that file contains a virus or not. So there are a lot of background processes we may have, and that processes also need to take some time and storage and processes. So when we talk about this type of process, we always thought or look into the asynchronous way of processing, because synchronous is kind of very costly to us and it is not even scalable. So there is some calculation, like if each file contains 5 input output operations, right, and the time required for one input output operation to do is 0.015 seconds. So while doing this calculation according to the number of users and files we have to process, then it is around 1500 days. So 1500 days, if it is kind of synchronous and we have only one process and we are doing things one by one, but we don't want to do that. So we are basically in that case, if we basically use 5 processes with 50% capacity of our system, then it is around 6000 processes we may need. And in order to increase this process, we may have more machine, which is like horizontal scale mean we will add more distributed machines, and we will parallelly do all that process, so that we can reduce the whole time. And this takeaways I already give you, means read is always greater than write, and always use the approximation value. And whenever there is a kind of processing, use asynchronous way of handling the data, so that actually make your application decoupled and even background compatible. Now, so whenever we are going to build any application, obviously we need something. So I basically write some of the services that we may need in building the Gmail. So that is the gateway service. We will talk one by one about each, don't worry. Gateway is nothing but the entry point of our application. Whenever someone try to connect with our application, it first goes through the gateway. Gate may take a lot of responsibilities, but in our case we are having only 2 responsibilities. The first is it basically redirect user to the perfect route, and the another is we are using the rate limiting, so that if some hacker or someone try to shoot million of or crore or that number of requests that we are not even thought of, then in that case rate limiting is a very great thing. We can basically stop all those people to directly access our system. The another is service registry. If you think in the case of Node.js application, you can think of that file that contains all the mapping between the route, and that route is then attached to some controller or service layer, where we are basically handling all that request between different requests using different services here. Then we have auth service, profile service, email, search service, fraud, attachment, queue, and cache. We will talk about this service later. We will move on, but there is two things, which is queue and another is cache. So why we are using queue? Mostly we are using queue because we can put millions of data in a queue at a time, and then we can pull data from the queue, and we can work on the data easily, or we can work on the data in a normal way. In that way, our system, if our system is flooded with a lot of requests, our system don't go down. It basically take all that request and process each request one by one slowly, or whatever you want, however you want to do. And cache is nothing but, cache is a very fast kind of memory which is very close to our application layer. And if you have, let's suppose, something that you need to persist some data, and that data is present in the database, Postgres kind of database, then that data you need to fetch multiple times. So that is a very, that request may take some more time and make your DB slow. So in order to reduce all those things, so that we get the faster request, or already processed data we have, we can store in the cache, and then that data can be used easily, and it is literally really fast. Okay, now let's see how basically we can register a user in the Gmail, and with the two-factor authentication system, how we can do that. So if you see this is the user registration flow. We have a client and we got a request for the registration, and we basically have the gateway. That gateway have the rate limiting and all that, where that request go to which route. We have a cache layer also. Sometime, let's suppose this service registry that having the map of the route and the service layer, this is not going to change every time. So we can also cache that in our cache, so that every time we don't need to travel from there to there always. We can simply use the cache, and we will know like where we need to redirect this request. So this is the request for registration, so it is obviously handled by the auth service. What we will do whenever there is a user come for registration, we simply take that user, check it on our database if that user is already there or not. If that username or that email is already there, then we will say that user is already there, you can't create the same user with same email or username. And if it is not there, we simply create the users. And once we create the user, we basically need 2FA, like two-factor authentication. So here you can see we have a authentication service. When we create the user, we basically add that event in our queue, and that queue is then basically consumed by the email or SMS service. So let's suppose when you create a user, we basically create an event in this queue, like this user is created, now please send the email or please send the OTP to that user for 2FA. So then this email service is responsible to make an OTP request with a proper TTL. TTL means like till when that OTP is valid, of like when we have to discard that OTP. So there are a lot of things like we can store. So basically this, when we send the OTP, we can create an entry in this DB where we have the email and we have OTP, whatever the time of OTP, and we can also have a created date using created, like when that OTP is created and what is the validity time validation we have, we can calculate like when we have to discard that OTP. Or the another or the best way to handle this thing, because let's suppose whenever someone try to verify its user, right, we need to call that email DB, like okay, tell me the OTP is valid or not, something like that we need to do. But that is, again I told you, if someone do this thing multiple times, then we need to call a lot of database calls. That is not good. So in that case, whenever we send the OTP and create an entry here, we will create an entry in our in the cache, and in cache we have ability to create the TTL. So TTL is like we can create a key and we can add a timer to that key, like okay, after 15 minutes you will be destroyed. So let's suppose if anytime there is any user come for verify, right, we can simply check if that user is present in cache, and that OTP, obviously we store the OTP, right, and the user is verifying while passing the OTP. If that user is present in the cache, it means like the OTP is valid, and then we will check the OTP we store in the cache and the OTP which is sent by the user, if it is same or not. If it is same, we basically verify the user, and this is the column where we value store the value true or false. Once the user is verified, we will make this value true, so that next time the user comes, we will know that user is a verified user. Now we have again a profile service. So let's suppose when the user is created and verified, they can add their data, they can add their name, they can update their general profile or whatever it is, and that is going to be handled by the profile service. Now let's understand how we can send an email or how we can do search in emails. You know that in your Gmail you can search anything. Let's suppose you can search content, you can search any keyword in your email, and you can you get the email from that number of emails, right? So in order to make sure that all those functional things work properly, we have some component, like we have email service. That service is responsible for receiving the email from any external uh, user. We can send the email to a different domain even. And also like whenever someone search the keyword, whenever search some keyword, this email service is again obviously using some search engine. We will talk about how that search engine works, everything. And then that search engine return all the emails that actually that actually matches this keyword, and then we can return that emails, right? Then we have need a message queue. Why we need a message queue? Because there are a lot of emails, as I told you, 4.400 billion, sorry, 4.5 billion reads, and around 1 million write emails every day, every second. So that is a huge thing. To cope this, we will basically use a queue. We will put all the emails in that queue and then process it one by one using the SMTP or IMAP server. What is SMTP and IMAP? We will later discuss on that too. Now we will use the search engine service. Search engine, we can use Google search or Elasticsearch, that actually basically create a inverted index. What is inverted index? So you can think of something like let's suppose you have an email, and that email contains hey Sandeep, something like that. So what people will do, we basically show okay, this email contains hey and Sandeep, and that actually makes that indexing very slow. What inverted index will do, we basically create a hash map with value like hey, and we will see that this hey word is present in how many emails. So we can simply create an array like email 1 and email 3, these two email having this word hey. So if someone search hey, we can use this index, which is very fast, and we can see okay, there are 20 emails that contains hey, and we will return all that emails to the user. And that is how our search engine basically works. And then we have a spam detector. That spam detector will basically read the subject body of that email, and with the help of fraud detection or spam detection machine learning algorithm, we will find that this email is spam or not. And it basically happens when we put that email inside the queue, and then spam detector will pull emails from the queue and work on that. And then we have distributed file system, that basically store all that email content in a kind of you can think of a huge file system like S3 bucket or something like that. And then we have a preference service. Preference service simple means that preference service simple means that whenever we have opened the Gmail, then we have sent, received, or that preference is what we need on our Gmail. According to that preference, we store the emails in that bucket. Now the another feature that we actually want to build in this Gmail, that is called as contact and group. So let's suppose if you are sending email to someone, or someone send you the email, then we need to create a contact, right? So let's suppose you send a email to someone. We can't directly say okay, there is a contact between A to B, because it may happen that B person is not available, or that address you are trying to contact with is not present, right? So this thing always happen when an email is processed. Okay, so let's suppose you send an email from A to B. we basically we basically use the email service, send that email through SMTP server. Okay, and once we basically send that email to the SMTP server, that email is processed. We basically store that processed email in another queue. That queue only contains processed emails, and once the email is processed, we know there is a B in this world present, so we can use this contact service. That contact service basically pulls the email which is present in the processed email queue, and then create a mapping between sender to receiver, and that's how we can create a contact. What is SMTP? What is IMAP? Simple Mail Index Protocol. This is the definition, and IMAP is Internet Message Access Protocol. So SMTP is mostly used to send the email, and IMAP is mostly used to receive the email from any domain. Okay, and this is a very simple architecture diagram of the Gmail. We have the client, and when someone tries to send the email with the attachment, we don't directly add the attachment in the whole request body. We basically use a drive. We basically add that attachment in that drive, and whatever the drive link or the address of that attachment we got from this drive, we basically put that in the request body. Then we obviously we use the gateway for error limiting and everything according to the route. It basically sends our request to that service, and this is a kind of microservice architecture. Each service has its own database. Okay, so once we get the data request, so if it is a registered request, we basically use the auth service. That auth service do all the validation user is present or not. If present, it basically use this SMS service or email service that basically send the OTP, and after sending the OTP, it basically here there is a flow. It basically use the cache, and it basically use DB where it stores the OTP and stores the OTP in the cache too. So once we have the OTP here, the user can verify according to the logic I told you before. And here we have a profile service where we can add our profile photo and all those things. And if you see the gateway, we basically if there is a request of sending an email, this is the email service. What that email service will do, whenever there is a request we come in, it basically put that into the email queue. This is the queue that contains all the email. Then that queue is basically, that SMTP server is basically pulling data from this queue and sending that email to different people. So once we process the email, then this data is stored inside the processed email. Now we have all the data in our processed email. As I told you, once the email is processed, this queue is then basically used or pulled by the preference store. We have the contact manager and search engine, right? So this search engine create the inverted index. This preference store create the preference, like maybe there is another service which is a spam we talk about, right? That spam is basically working on these processed email and add them in different preferences, like whether it is a spam or it is a social or whatever the preferences user have. Accordingly, we will put those email in different buckets, and obviously they have different databases. As I told you, it is a microservice architecture. And then we have a contact service, because we know that in that process email there is a sender and there is obviously a receiver, and according to that mapping we create a contacts here. So obviously there are a lot of questions you may have, like if like in what edge cases that OTP may not be verified properly or 2FA can be filled. Yeah, but it is a very huge system. This video actually contains the very high level of thing you can start up with an interview, because in 1 hour of interview you can't basically consume all the aspects and you can tell about each and every aspect. When you start working on this in an interview, maybe they will focus on only 2FA, or maybe they will focus on how the send email is actually working according to DBA and all. If you have any questions, obviously ask me, and I will try to put more and more videos related to system design. Thank you.